quotient rule, where we said that quotient means the result which you get after dividing two numbers, where we said that the quotient of 4 over 2 is what? 2. The quotient of 6 over 2 is what? 6 is 3, right? So quotient simply means the result which you get after dividing two numbers. Now we also said that we use quotient rule of differentiation or quotient technique or quotient method of differentiation when we have two functions dividing each other. When we have function like this in this form, when we have this dividing this, right? Now look at this example on the board. Let's solve this. Given y equal to x cubed minus 4x minus 3 over x squared, find dy dx. Solution. Now given this, what's the formula for a quotient rule? You said that in the quotient rule of differentiation that given that uv is a differentiable function of x, right? Here you have that f of x is equal to u over v, right? Then your f prime of x, which is equal to what? Dy dx is equal to keep v differentiate u with respect to x minus keep u differentiate v with respect to x all over v square. Is that correct? Now from this, where is our u and where is our v? Our u is the numerator, our v is the denominator. Is that correct? Now from this, we have that our dy dx is equal to give v differentiate u with respect to x, differentiate this whole thing with respect to x, right? Minus keep u differentiate v with respect to x. What's our v? This, right? All over s power 2 raised to power 2. You now differentiate. Now that your dy dx now is what? X squared times. We differentiate this, each and every one of these, using the normal general method, the power rule. I will say that given that y is equal to s power n, then your dy dx is equal to what? N s power n minus 1. This is what we are using. Now this n will come down to multiply this base. You now subtract n by 1. This is what we'll do here, one after the other. Is that correct? Now if we differentiate x cubed, we have 3x power 2 minus differentiate minus 4x, you have 4. We differentiate this constant, you have 0. So here again, you keep this. If you differentiate this, you have 2x. Is that correct? You have x power 3 minus 4x minus 3 all over x power 4. Is that correct? Now, you use this x squared to open up this bracket. Also use this minus 2x to open up this bracket. You get what? That your dy dx is equal to x squared multiplied by 3x squared. You have 3x raised to power 4 minus 4 times x squared. You have minus 4x squared minus 2 times x cubed. You have 2x raised to power 4 minus this minus will give you plus, right? Minus then 2x times 4x will give you what? 8x raised to power 2. Is that correct? Then minus 2x times minus 3 will give you what? Minus will give you plus first. And use this to multiply this, you get 6x all over x raised to power 4. Now, you simplify further. You do what is called collection of like terms. You have x raised to power 4 here, you have x raised to power 4. You bring them together, you add them up. Then you have x raised to power 2 here, you have x raised to power 2. You add them up also. Then you have your dy dx is equal to x raised to power 4 minus 2x raised to the power 4, we have x raised to the power 4. X raised to the power 2 minus 4x raised to the power 2, we have 4x raised to the power 2 plus 6x all over what? X raised to the power 4. Now, this is your dy dx. Is that correct? This is your dy dx, the first derivative. Let's solve another example. Let's call this one example 2. Example 2. Given the, okay, find the derivative of what? Y equal to x raised to the power 2 minus 3 over what? Let's say x raised to the power 3 plus 5. Is that correct? Now, find the derivative of y equal to x raised to the power 2 minus 3 all over x raised to the power 3 plus 5. Now, we use quotient rule because this in a fraction form. We have this in a fraction form. That means x raised to the power 2 minus 3 is dividing this. Is dividing x cubed plus 5. Right? So we use quotient rule. We start solution. Solution. Then your dy dx is what? You keep v, right? What's our v here? Our v is the denominator, our u is the numerator, right? You keep v. You differentiate u with respect to x. Abi? Then you keep u. Then differentiate v with respect to x. Right? All over x raised to the power 3 plus 5 all power 2. Is that correct? Now you have that your dy dx is equal to x power 3 plus 5. If you differentiate this, you have 2x, right? Minus. If you differentiate this, you have 3x power 2. This one will give you 0. Is that correct? Then still have this here. Minus 3. All over x raised to the power 3 plus 5 raised to the power 2. Is that correct? What do we do further? You use this to open up the bracket. You use this 2x to open up this bracket. You also use minus 3x to the power 2 to open up this bracket. Right? You now have that your dy dx is equal to 2x times x cubed will give you 2x raised to the power 4. 2x times 5 will give you 10x minus 3x squared will give you times x squared will give you minus x raised to the power 4. Then minus 3x squared times minus 3 will give you what? Minus times minus first will give you plus, right? And 3 times 3 will give you 9. You have your x squared all over what? 3 raised to the power x raised to the power 3 plus 5 all raised to the power 2. Then we collect like terms. We collect like terms here. Is that correct? 2x raised to the power 4 minus 3x raised to the power 4 will give you what? Dy dx is equal to give you what? Minus x raised to the power 4. Right? Plus 9x raised to the power 2 plus 10x all over x raised to the power 3 plus 5 all square. Now this is your dy dx. This is the derivative of this. As simple as that. As simple as that.